Hello, welcome to class. Today we're going to look at the second section in chapter 7, 7.2, and the main purpose of this section is to elaborate on what we discussed a little bit in section 7.1 about domain and range. And so today we will look at almost exclusively just picking out those x values of the domain and choosing the y values of the range given a graph. And then we just do a little piece with something called a piecewise function. So if you've seen that, if you've worked ahead in your homework or anything, that might ring a bell. And that's a topic that kind of tends to revisit every once in a while as well. So just to recap from section 7.1, the domain is your x value, the range is your y values, and then we need to talk a little bit about notation, so how our answer is going to look. There are multiple different ways that we can write domain and range. One of them is by using an inequality or a compound inequality. Another way to do write domain and range is using set notation. And I looked ahead, this is my first semester using MyMathLab, and so they do utilize set notation in two instances only. One, when your value is all real numbers, and so let me just double check my notes here. They write x such that x is a real number. And the set notation is indicated by these little squiggles. You don't need to make those, they're already in the computer for you. And then if there is one particular gap or a hole, it looks like this, x such that x is a real number. And then you'll see a comma, but you can tell I'm kind of running out of space here. X does not equal, and then whatever, where the hole is. All right, and I'm using x as my primary example. It could be the range that you need to write like this. And so you may, in fact, be using the letter y instead of the letter x. So there's also something called interval notation, which I think you do utilize when you move on to college algebra, pre-calc, and calc. But I noticed that MyMathLab does not utilize interval notation at all. So interval notation is when you have either the bracket or a parenthesis talking about whether or not it includes or does not include a number. And it is something that you might have seen in a previous math class. We're not going to use that for these examples today. All right, so our main goal, all six, state the domain and range. Every problem has a little bit of a twist. I have two more to show you after these six, just to give you a broad base from which to work on for your homework. All right, so let's look at this one. We have a continuous line, and so we are in between, here's our x's, here's our y's. Let me give you some general strategies here first. For the domain, you want to look left to right because you want the smallest number. And of course, along the x-axis, the smallest number is over to the left to the largest number, which as we move further and further to the right, think about these values, 1, 2, 3, 4, 5, and then all the way to infinity. So we're going to go left to right. This one is continuous. So x can be any value between this value and that value. So the way we write this using an inequality, and I'm just going to erase this. You can go back and pause and write that in your notes. But my domain here, x is in between -4 and 1, 2, 3, 4, 5, 6, and 6. Because these are closed circles, our inequality it includes the numbers -4 and +6. So we draw those lines as well, showing that it includes them. I have one here that's an open circle. You'll see what I do when it's an open circle. It's just a little bit different. All right, the range. Range is going to go bottom to the top, lowest to the highest, okay? Because our y values, think about where the y values are the smallest. Y values are the smallest as you continue going down the y-axis. Y values are getting bigger and bigger and bigger as you continue going up the y-axis. So we're going to go low to high, all right? So the y values go low to high. All right, and again, I don't want to mess up, I don't want to confuse anything. For further examples, so you can write that down, and then I'm going to erase it real quick. All right, so our domain here, if I go low to high, the bottom number here looks like it's about at -1, -2, -3, -4. Just a coincidence that they are the same there. And then it looks like I go all the way up to a +1. And again, because those are closed in circles, I have to include the equal to part of my inequality. So there's our first example with domain and range. All right, let's move, instead of going down, let's move across. So let's do this one next. I can even label these A. All right, so this next one, it is continuous, but it also goes forever in both directions. So these arrows indicate that it goes all the way to the left forever and ever and ever, so that direction would be -infinity. It is continuous in the right-hand direction, so it would go forever and ever, getting larger. So therefore, my x values span all real numbers. So there is a way to write that, -infinity to infinity. So my domain here would be -infinity. Oh, you can't ever reach infinity, my bad. We don't include that because you can never actually reach infinity. Or, and you'll just have to take your clues from My Math Lab and what the choices are, or you use this option right here and you write your answer in set notation. X such that X is a real number. All right, let's look at our range. Perhaps I overestimated my ability to write small here. My range, if you look at my y's, no matter where my graph lands, my y value is always the same. It's always down 1, down 2, down 3. Y equals 3. It's the only element in that set. That is the range every single time. Y is 3. It doesn't matter what point you pick. You could go out 10,000 spaces to the left. Y would be, -3. -3. It's down 3 every single time. All right. This one. Much different. Now we do not have a continuous graph like we do here. So it's not flowing. It's very specific dots. When you have very specific dots, you are going to list every member as a finite set. Okay? So your domain, let me just double check that I am still in camera. Yeah, but not much in camera. My domain, it looks like, well, we could just write the coordinates here. So -5, -5, 7. This point here is about -4, 3. This point here is negative 1, 0. Here we have 1, negative 2. Here we have 3, negative 3. And here we have probably 5, negative 7. All right, so we are going to list the very specific members of the domain and of the range. They typically go in order from smallest to largest. So you do want to try your hardest to put them in order. So the domain, again, we're going to use set notation because it is a finite set of numbers. And you're just going to list all of the x's. So I hope I'm staying on camera here. Let me write it maybe up here. Domain is negative 5, negative 4, negative 1, 1, 3, and 5. And the range are my y values, again from lowest to highest, from smallest to biggest. So we're not going to look left to right, we're going to look down to go up, okay, lowest to highest. So I'm going to start here, and I'm going to say, well, we include negative 7, negative 3, negative 2, 0, 3, and 7. So each one of these has a little bit of a different kind of twist. It's still doing the same thing. What are the x's? What are the y's? But depending on what your graph looks like, your answer is much different. All right, let's look at this one. Domain and range. So domain left to right. It looks like on the left I go to about negative 7. It does not include negative 7. And then I get bigger and bigger and bigger and bigger and bigger, and that arrow goes to the right forever. So x is in between. Well, here, let's write it up. Sorry. I had two different schools of thought on how I'm so conditioned for interval notation. It's how I normally teach this, that my brain automatically, I had to adjust a little bit. X has to be greater than negative 7. It's all values greater than negative 7. There is no line here because it does not include that. So negative 6.9999999 is fine, but the second you actually get to negative 7, it is not in the member of the domain, so we do not have a line right there. All right, the range, similar, not exact, low to high. Where are we? We're at about negative 2. So negative 2, and then we rise, and as this graph goes forever, so does our range. So y is greater than negative 2. All right, on E. So we have yet to look at a graph that dips down and then goes back up again. This is an absolute value graph. It makes a shape of a letter V for value. Well, that's not Y, but it's conveniently coincidental. V for value is the shape of the graph. We're going all the way to the left, all the way to the right. It's continuous. And so there are no x values that the graph really does not include. So the domain here is going to be the set of x such that x is all real numbers. There is an easier way to write that, but that is not what MyMathLab does. If you're familiar with the shortcut, kind of that double R, that stands for all real numbers. I haven't noticed that in your homework program yet. All right, let's look at the range. Again, down to lowest to highest, down to up. So it looks like my lowest is, well, depending on how you interpret my little homemade graph here, it looks like my lowest value is about at 1. Okay, that was my intention, is to make it kind of right at about 1, and then it goes up from there. So y is greater than or equal, because it does hit that 1. All right. Last one. This one kind of looks backwards because my dot is on the right, so this one tends to be a little bit confusing, which is why I definitely wanted to show you an example. You're free to try any of these, obviously, if you'd like. Domain and range. Domain and range. So lowest left to right first. I almost said lowest to highest. Here are my x values, left to right. And so it looks like my graph goes to negative infinity forever, and it looks like the largest value it ever becomes is positive 6. If this is the point, positive 6, and where do we think this is? We'll make this one negative 2. It's a little bit here. When in doubt, I'll just move my homemade line. There we go. All right. So it looks like this is the largest x value to the right, and it's everything smaller than that forever. So when I write that as an inequality, x is less than or equal, because it's a shaded in dot, 6. When I think smallest or lowest to highest, smallest to biggest, my range, the smallest value is going to be negative 2. That's my y value right there. And then the graph is going to continue to go up as it goes to the left. So y is greater than or equal to negative 2. All right, so there's the first 6. You might want to fast forward while I'm erasing. And we have 2 more with the instructions state the domain and range. Feel like I should have some background music or something going here. At least my dog isn't barking, the phone isn't ringing, kids aren't storming the staircase. All right, this one I have, this, and this one. Forgive me that I'm using the same colors. I just wanted to show you one where there was both, and what the graph is doing is inconsequential, and we'll make that right there. Okay, I just wanted to show you one where there was an open circle and a closed circle, and this right here is called a parabola. It's what it looks like when we graph a quadratic, which is all of those equations that you factored back in chapter 5, and this is what is coming in chapter 11. If you recall quadratic formula from maybe past math classes and things like that. All right, domain and range, here we go. So here are my x values, left to right. It looks like x is anything in between continuously, 1, 2, 3, 4, 5, 6, negative 6, and 1, 2, 3, 4, 5, positive 5. And it is continuous, so I'm going to put x smack dab in the middle between negative 6 and 5. Because it includes the number 5, make sure that you draw the line there. But this is an open circle, so it does not include the negative 6. Low to high for the range. I'm really struggling with saying that expression. Low to high, down to up. It looks like this. We'll make this at negative 3. Use your imagination. And so it looks like we go from negative 3 all the way up to 1, 2, 3, 4, 5, 6. So negative 3 to 6. It includes the negative 3. So the line goes there on the left-hand side this time. But it does not include the 6. And so you have your underline on opposite sides for this one. All right, last one. So there's arrows there that indicate that that graph is going to continue, and even though it doesn't look like it, it will continue to get wider as the arrows continue to go down kind of slowly. All right, but it will span the entire x-axis by the time it is done. So my domain is x such that x is all real numbers. Oh, I'm going to show you one real quick with a hole in the graph too, so that you have an example of that in your notes. And then the y value, it looks like positive 1, 2, 3, 4, 5 is the highest, and then it's all the values under that. So y is any number less than or equal to positive 5. And because it does hit that point, you include the line underneath. All right, bear with me for one more example. Again, I'm trying to help you out here. So, feel free to print some graph paper when you're doing your notes for this lesson. That can sometimes be a little helpful. Let's make the hole right there. Hopefully that looks kind of line-ish. All right, because I did them separately. So domain and range here, the domain and range are all real numbers for both. It's killing me a little bit to have to write this out every time when there's so many other ways to write this. And y such that y is all real numbers. And then there is one exception to that, and that's right there where that hole is. So you have to identify where that is. That one spot is -3, 1. And so what you'll see here in MyMathLab is you will see that there will be a comma, and then it will say exactly where the one point is x can't be. X can't be -3. Y is all real numbers except for the one place where there's a hole. Y can't be, +1. And then we close up our set notation here. Again, you don't have to draw those. They're just already in MyMathLab, and you're just putting in the other choices from what I could see when I looked at your homework. All right, so that is everything you need to know about domain and range. There's one other thing I think sometimes students really struggle with this. I would encourage you to look at my suggested homework. That is what I would typically assign if we were doing problems out of the book and meeting in person twice a week. Just to give yourself a little more practice if needed. It is just a concept that some students graphically, it is just a little bit tricky sometimes. And the fact that every problem looks a little different adds to that level of difficulty, I think. All right. Last problems in 7.2 are something called piecewise functions. The good news is we don't have to graph them. You don't have to create them. You just need to evaluate. So piecewise functions have different pieces to them. So they have the perfect name. So we're going to have our function be 2x plus 5 for x less than or equal to 3, and minus x plus 1 for x greater than 3. So a piecewise function has two different equations in one. For some members of the domain, you would use the top function. If your value that you are substituting for is in this category, greater than 3, then you would substitute it into the bottom function. So you will look at homework problems of different values. And it's important to note you're either going to substitute for the top or the bottom, not both. Some students want to substitute in both places. You have to make a choice with a piecewise function. It's this or this. So if I was substituting in x equals 4, is 4 less than or equal to 3, or is 4 greater than 3? Well, 4 is greater than 3, so you're going to substitute in for the bottom equation only. So you're going to use that. Substitute the 4 in for x, and the answer is -3. If you're substituting exactly 3, we call the point where it transitions the cusp. That is the official mathematical term. So if you're given the cusp number, you have to choose by where it is equal to. So where the line is underneath the inequality. So this is x less than or equal to 3. So what is the function value at exactly 3? Plug 3 in right there. So 2 times 3 plus 5. 6 plus 5 is 11. Which function would I use if I wanted to plug in x equals 0? Well, again, you have to make a choice. So is 0 less than or equal to 3, or is 0 greater than 3? 0 is less than 3, so I'm going to plug or substitute it in for the top equation. And you only ever get one value. You made a choice, so you're not going to get 2 answers. You're only going to get 1. If you'd like to try one of these, let's make g of x equal to -x minus 6 and 3x squared plus 11. Of course, I'm going to make it harder. Because that will really see if you've got it. And so let's do f of 0, f of -10, and that one right there. All right, so pause the video, see how you do. At 0, we have to make a choice. Is 0 less than -4 or greater than -4? 0 is bigger than -4. So this is the equation I'm going to use. So I'm going to say, okay, 3x squared plus 11. Substitute in 0. Anything times 0 is 0. So my answer is 11. Now I'm going to look at -10. X is less than -4, -10 is less than -4, so I'm going to use the top equation. So -x subtract 6 more. Notice you're going to have a double negative right there. So 10 minus 6 is 4. The last one, which equation am I going to use with just a +2? 2 is greater than -4, so I'm going to use the bottom equation here. So 3 times 2 squared. Oh, it occurs to me I might be off screen. I apologize if I am. 2 times 2 is 4, times 3 is 12. 12 plus 11 is 23. Let me see here if I can turn my camera real quick. Yeah, I might have messed that up just slightly. So let me turn my camera real quick so you can see everything. All right, and that wraps up 7.2. Chapter 7 is super short. There's just one more section. That's why it's combined with Chapter 6. So I'm hoping that this gives you some balance to some of the questions in Chapter 6, because I know that is a challenging chapter full of nothing but fractions. So have a great day, class, and reach out to me if you are having struggles. Thank you.